Recording in progress.
Okay, let me do the even or right sides of this. So here's how I would go about simplifying radicals. Now, if you have a calculator, you can punch in the calculator, but sometimes you still have to simplify and kind of figure out how the final answer should look, because some stuff will stay inside the radical, some stuff will leave the radical. How do you determine what leaves and what stays? Let's look at 216. Now, if you're ever stuck, one thing you can do is divide the number by 2. Break it down. What if I divide 216 by 2, I should get 108. Continue the breakdown. That should be, now if you could divide by other numbers by 2, go for it. But that's 54 and 2 again. That's 9 and 6. Okay, I'm gonna stop right there, because if you think about it, that's root 9 times 4 times 6, right? Because what's 2 times 2? Of course, that's 4, right? Because I pull these two 2's out. And of course, I have v still inside. You can now break it off like this: root 9, root 4, root 6, and root v. You're allowed to do that with square roots. You can break them down to individual square roots. That's because of square roots and exponents. I know we haven't talked about that yet, but square root is actually an exponent, and you're allowed to use that as a property. What's root 9? What's root 4? And then 6 and v are not perfect squares. Leave them inside. So you get 6 root 6v. That's how you can simplify it. So it's a very methodical process, because sometimes it can be random too. Like, well, how did I know 36 is a factor of 216? That's tricky to do mentally. I mean, if you could do in your head, hey, 36 times 6 is 216, more power to you. I have a hard time with that too, and I do this for a living, right? So I like to break down numbers in an easy way. Divide by 2 or divide by 3 until you find factors that are perfect squares. Pull them out. Whatever's not a perfect square, leave inside. Let's try it again for 4. Let's break it down. Divide by 2. And of course, if you have to use a calculator, it's totally fine. But I know it's 256 and 2. Okay, I do know that 256 is a perfect square. I know that. But maybe you don't. That's okay. So 128 and 2. 64 and 2. Okay. Now let's think about it. Is 64 a perfect square? What's the square of 64? Great. So you have root 64. And I have these two 2's, which is a 4. I have another 2. I have m cubed. Now m cubed, I'm just going to leave it like it is right now. So I have root 64, root 4, root 2, and root m cubed. Does that make sense so far what I've done? How I broke it down? Again, there's no hard and fast rule of how to break it down. I mean, you can just really do whatever makes sense. But divide by 2 is what I decided to do. And I kind of stopped when I got down to 64, because I identified a perfect square. And I know that's 8. And I have 2 2's, which is 4. And another 2, which is just 2. So I broke it down like this. Now, what's root 64? What's root 4? Okay. Now, the part is tricky, the variable, m cubed. M cubed is m times m times m, or it's m squared times m. Same thing, right? If I square root m squared, what's the square of m squared? M. And root m on its own, just root m. So one thing you can do when you're square rooting is ask yourself, how many times does 2 go into that number? Once. Pull it out. What's the remainder? 1. Leave it inside. So you can think like a division problem as well. And it'll make more sense once you start getting to fraction exponents. That's yet another perspective you could take that will help you get a deeper understanding of this stuff. But it's definitely m times root m, because I'm taking the square of m squared, which is m, leaving behind a root m, 16m root m. Does that make sense? How I got that one too? So the last one, number 6, if you think about it, that's a perfect square. So that's 10. And how many times does 2 go into 3 for v cubed? Or how many v's can I pull out? So you pull out v squared, but what's the square of v squared? So v, and you leave behind a root v. Boom. Got it. Okay. Good. Okay. Now, cube roots, how are these done? These are a little tricky. Let me help you with, let's do a couple. I'm not gonna do all 80s because that's kind of crazy. I'm gonna do a couple and we can revisit this next week as well. Okay, for number one, cube root 250x5. All right, so break it down. Let's break it down. That's, I could do 125 and 2. Oh, let me space out a little better. My apologies. Break it down more. The little tricky about 25 and 5. That's 5 and 5. Now here's the thing. You got the landscape has changed. It's not square root anymore. It's cube root. I want 3 identical numbers, not 2 anymore. Because remember, 64 is cool for square. That's 8 and 8. Or 4 is cool. It's 2 and 2. 9 was cool. That's 3 and 3. I need 3. Do I have 3 identical numbers here? I do. What is it? 5. Yeah. So you can think of it like this: the cube root, because all came from this, right? Of 125 times 2 times x5. Or break it off like this. So I still want to be incredibly consistent to what I've done previously with square roots. I don't want to change things up too much. The cube root of 125 is 5, right? Because 5 times 5 times 5 is 125. Now let's look at x5. x5 is x multiplied how many times? 5 times, right? Can I rewrite as x cubed times x squared? Sure. And what's a cube root of x cubed? When you cube root a cube, don't they knock each other out? Don't they undo each other? If I cube root x cubed, that's just going to be plain old x. If I cube root x squared, forget about it. I just have to leave it like it is. So what you're going to do is a little different than square roots. Instead of doing this exponent divided by 2, you do this exponent divided by 3. How many times 3 go into 5? Once. What's the remainder? 2. Take down x, leave behind 2 x's. So it becomes x times the cube root of 2x squared. Let me try it again so you see the pattern. Let's try again for number 3. 3 is a good one. And then I think we can move on to the homework review. And don't worry, we'll still keep reviewing this because it's, you guys need more practice with it. Let's take a look at 3. Let's break it down. I'll leave the one down below exposed so you guys can see that. Okay, unfortunately, 135 is not divisible by 2. Hey, Nathan. Is it divisible by 5 or 3? Did you have COVID or? Okay. Thanks. Did you have any symptoms? You're okay? You're feeling okay? You're good? Good. Okay, cool. All right. All right. Anyway. So we'll put Nathan in a bubble. You got a bubble. Okay. All right. Didn't we used to call it that, like the bubble, like, or 6 feet? Yeah. Gosh, that was 4 years ago. That's crazy. Actually, I remember 4 years ago, I would come to this room to do my Zoom calls. No one was in this building. And it was like orange sky outside because of the fires. And, yeah, I actually have pictures. I'm going to see if I can, yeah, I was actually driving the Bay Bridge that morning and it was pretty crazy. Yeah. All right. Okay, guys, let's get back to this. I know got us off track. Okay. And Nathan, we're just going, yeah. Let me get the notes too. You were not here the other day, so they're new notes. Okay. Hey guys, I know Nathan got us excited, but let's get back to this. Okay. All right. So anyway, use a calculator. Guys, quiet. 27 times 5 is 135. So use a calculator because it's not as obvious how that breaks down. Now, is 27 a perfect cube? It is. What do you multiply 3 times to get to 27? 3, 3, 3, exactly. So I'm going to rewrite this. Let me clear the other junk down below. All right, so let's break it down like this. Cube root of 27, cube root of 5. And to be kind of really frank about the way to go about this, as you get really good with this, you don't have to keep doing it this way. You could just sort of just do it. But in the beginning, I think it helps be more methodical, right? What's cube root of 27? 3. Now think about the cube root of M8. For variables, you got to treat differently. How many times 3 go into 8? 2. What's the remainder? 2. So take out m squared, leave behind m squared. And of course, there's a 5 that joins the inside as well. And that will guarantee that we have the same thing. So that's the process to go through. So I won't do the rest of these. This is something we could probably just do at a later time, but I just want to at least have that discussion on it. Okay. Now let's move on to the homework. B4. Okay. So here's how you do this. These are the same. That's because this right here is 2 to the negative 1 raised to the x, which is this, 1/2 to the x. So those are the same. And so, do you need a packet or which one? Yeah. Oh, here. I'll toss the other one. Okay. All right. All right, guys, let's keep moving. So those are the same graphs. If you were to graph it, because 2 to the negative x is 2 to the negative 1 raised to the x. Negative exponents flip. So it's the same thing. That's what you notice. And all these here are pretty straightforward. That's 5. That's 1/100. That's 8/5. That's 9, because you got to do 3 squared. That's 1/32. That's 2/3. That's 1/216. I'll slow down a little bit in a sec. And that's 27/8. Okay, let me explain. So I went kind of fast. Sorry for going fast. Okay. Let's think about it. When you raise and when you have a negative exponent, you flip the base, or you flip whatever inside the parentheses. So what's 1/5 flipped over? That's it. That's all you do. What's 100 flipped over? 1/100. What's 5/8 flipped over? 8/5. Now we have to do a couple things. Flip and if I flip the 1/3 is 3. What's 3 squared? 9. There we go. Two things. I got flip and cube. What's 2/3 flipped? 3 halves. And I get a 3 cubed. 3 times 3 times 3, 27. 2 cubed, 2 times 2 times 2 is 8. You get 27/8. Flip it, that's 1/6. But 6 times 6 times 6 is 216. Flip it, that's 2/3. Flip it and raise to the 5th power. 1/2, 2, 2, 2, 2, 2 is 32. So hopefully that's the methodical way of thinking about it. All right, let's keep moving. This one here. Here's what you gotta do. The multiplier. So the general formula, which actually I do give you this formula. I think I give this formula. I have to double check. But that's generally what we do. Or actually, let me make it X instead. Okay. Why am I doing minus instead of plus? You lose and not gaining. And what's my percentage? 60%. But really, it's 0.6 as a decimal. And I'm starting with $80. So I'm actually doing part C first, which actually would probably be a better way to start, to be honest.
Didn't you say it's 0.4?
Becomes 0.4 after that. So your multiplier is 0.4. And B is easy. Just plug in x equals 1 and x equals 4. And you should get, excuse me, you should get the answer just fine. D is never. That's because this can never equal 0. That's impossible. It gets very close to 0. And if you graph it, it looks kind of like this. Questions were okay. How's it negative? What goes to Reggie? What was negative? Oh, yes. Yes, you are correct. Given the context, I just did a general graph of it. No, but technically we start at 0, right? Yes. No, I should have been more mindful. Thank you. You're being practical. I'm not being practical. I'm just being too mathematical. Yeah, because it starts at $80. Yeah. I mean, technically you could say like, well, what if went back in time? Maybe it was like higher. I don't know. Just we'll start at $80. No, that you're correct. Okay, for 48, that's just what we call foiling or expanding. I think in the interest of time, let me actually pull up the ants key. That might help speed things up. And I'll do any that you have questions on. But for me to go over each of these problems, I'm starting to realize it's going to take too long. So let's see here. That's 48. Gone too far. All right. All right, here we go. Let me expand. And I still need to get around to making the ants key for this. So those are the answers for 48. Hey, do you mind turn off the lights, please? Thank you. Perfect. Good. We got one more. That's okay. Or maybe. Yeah, good. Thanks. I appreciate it. Let me zoom in a tad more. Okay. Those are the answers for 48. Any questions on that at all? No? You guys are cool with expanding? All right. Okay, for 50, what you want to do for 50 is it's decreasing. So y equals $20,000. 1 minus 0.15 raised to the x power. Or in this case, we'll raise it to the 5th power. Because you're doing it for 5 years. And it's some kind of money value. I don't know what. I think it was $8,000 roughly. Yeah, 88.74. Okay, that's how you calculate that one. For 51, the equation represents money I have at the end of any month. What's its interest rate? That's 0.8%. You have to move the decimal point 2 places to the left. Sorry, to the right to get the percentage. And write an equation represents your total money if you invest $500 in an account with the same rate of return. So you just do that. And I think that's all we need to do for that one. You don't have to simplify. That's it. No. M should be the exponent. I don't know why it's there. Yeah. Anyway, let's keep moving. Okay, for 60. Okay, there's a problem kind of like 6 in the homework quiz, but it's a little different. I'll explain in a moment. But what's the initial value here, guys? What's your A value? Okay, and then you have another point where at 1 comma 7. So 7 equals 4 times b to the 1 power. What does b equal? 7. Perfect. And that's your equation. Y equals 4, parentheses, 7/4 raised to the x power.
Yeah, that's a decimal.
That's fine too. If you have 1.75, totally fine. Okay, for 61, compound annually. Okay, great. Okay, there's something kind of like this in the homework quiz also. It's a little different, but the equation's simple. It's y equals 500, 1.08 raised to the x power. X is number of years, then plug in 16 for b. The domain is all real numbers. The range is y is greater than 0. That's always true for exponential growth or decay. And just plugging 16 for b, wherever that is, 61. Yeah, 500 times 1.08x, $1712.97. And technically speaking, it's not all real because you're not going to do negative x values, I suppose. And because you're not doing negative x values, let me do part C. My apologies. Given the context of the situation, it's when she was born, so you're not going to do this before she was born. So actually should have been that, and you start $500. So my apologies, I didn't understand the context well enough for part C. Yes, as an equation, I was correct, but given the context, it should be that instead. Okay, simplifying should be pretty. I'm not going to do the X for experts. Simplifying should be pretty straightforward. We already talked about this, so that's -10, 1/2, -5, and then four numbers will multiply 81. That's 3. That's 3. Okay. -10, half, -5, 3. We're good. Cool. All right. Let's get. Oh, and just really quickly here. So I want you guys to keep working on this throughout, the weekend and next week. Just remember for these kind of problems, I'm just gonna maybe just do a couple just so you guys see what's up. But remember, if you have x to the m times x to the n, what do you do with those two exponents? Add, hopefully. You guys know, okay. What if I have x to the m over x to the n? What do I do, guys? Subtract. Okay. All right, it's Friday. It's all good. Don't worry. I hope you guys know. And okay, how about this? You guys tell me. What do I do here? Multiply, I think, at least. All right. And if you have a negative exponent, you just put on the bottom like that. So if I look at number 5, for example, right? I've done this with a handful of you guys in the room here. Think of the top as being in parentheses and the bottom also in parentheses. And think of PEMDAS, right? Take care of everything inside the parentheses first or any exponents. But when I look on the inside or the top, 2 times 4 times 3 is 24. X squared x is x5. Y4 and y4 is y8. And down below I have this. Then I go vertically. 24 over 3 is 8. Then I subtract. 5 minus -3 is 8, so it's x8. 8 minus 2 is y6. So it helps to be very methodical about it. Clean up the top, clean up the bottom, then go vertically. Hey, let's compare the numbers. Let's compare the x's. Let's compare the y's. In this case, I'm subtracting the exponents when I do one on top of the other. So that should be pretty straightforward, hopefully. Cool. If I do kind of a wacky one really quickly, like 22, for example, it looks daunting, but if you think about it, this whole thing is being risen to what power? So that's 1. Then you have all this junk here. Now, every single letter has a negative exponent. Where do those go? Up top. So it's H3, J4, K squared, and 2. Just so you know, that's what you do. 2 stays where it is. All right. Let's get moving. Let me briefly talk about the homework quiz that you guys are gonna have in a little while. It's I this time I try to make it like the actual homework. So one problem is pretty close to 36. It's pretty close to that. So I just give you a situation, tell you increase exponential. I give you the formula too, by the way. I give you the formula as well, but it's pretty close to that. And another one is kind of close to B35, but I just give you the coordinates. I say here are a pair of coordinates. Give me the equation that it goes with it. So solve for A and B. And I give you the formulas on the homework quiz itself. So the homework quiz is going to be very similar to the homework from 2 days or 2 classes ago. Should be pretty straightforward. So I think you guys should be fine. I do provide the formulas. You definitely calculators allowed. Actually need a calculator, I believe, for one of the problems. So we're going to do after the lesson first. And I'll make sure you guys have enough time. So, all right. So let's move on to the lesson today. It's no, that's homework. So oof. Oh, so long. Okay, hold on. Let me pace myself here. Okay, extra for experts. Good. I don't have to waste my time with that. A lot of exponents. Okay. I feel better. All right, let's move on to B5. Let's talk about it. All right. The notes packet now. Let's go classwork B5. And let's do some sample problems. And then I'm going to talk about fraction exponents. And I'm going to kind of go back to this table here, which will help us at the end. So last page is a reference sheet. And we don't have to waste our time with page 3. So I think we get this done pretty fast. So my hope is to get this done in about 15 minutes, a short lesson, then homework quiz. All right. So Chase Bank offers 3% annual interest for a savings account. That's really good. Actually, usually it's much less than that. If you close your account mid-year, the amount of interest will be prorated. So Josie wants to deposit $500 in the account. Ryan question shows the amount with 3% interest rate compound annually. Now, remember the formula we had for compounding was this? This formula will be on the homework quiz, and I do actually provide it. And I actually tell you what each thing represents too. I do actually explicitly tell you what each thing represents. So you'll get that. Okay. What does P represent again? Do you guys remember? What's P? What's your principal? $500. Good. Okay. What's my interest rate? And I'm doing it how often? Just once. So N is 1. Because you're compounding annually. N is 1. So that's going to be 0.03. And then raise it to the X. We'll say X power. Okay. Or I can simplify it like this. A equals 500 1.03 raised to the X power. Okay, we're okay? All right. So that's going to be like part A of the homework quiz, by the way. Homework quiz is very similar to this. Very similar. It's actually a compounding annually question. That's very similar.
What's the point of writing 1 every time?
The one plus?
Yeah.
Um,
What if we just write the second one the first time? Is that fine?
Is this right here?
Yeah.
That's fine. That's okay. Yeah, sure. That's okay. Yeah.
Yeah.
Yeah, that's fine. Now, what does X half mean? So X is number of years. So it's half a year, right? And how many months is half a year? Or 6 months, yeah. Because she wants to leave this account mid-year. How many months will be a third? This would be 18 months. Let's just give some context, you know. What's a reasonable domain for this situation? Well, if she's going to close the account mid-year, I'd probably say my domain would be from 0 1/2, I'd say. Because you might close it, I don't know, after 3 or 4 months or 5 months. I mean, you could also do this too, I suppose. You could say that. Maybe you close after 11 months or 12 months, or I don't know. So that's just kind of open-ended.
How do you just choose?
Yeah, it's kind of open-ended. It's just because it said mid-year. Mid-year is like halfway. Because it said in the beginning of the problem, mid-year.
Okay.
So you don't open for a few months.
You're choosing the 1/3.
That would have been fine, sure. There's no right or wrong answer for that one. All right. So this is next we got to talk about. Let me jump to the last page of the notes, and you guys can sort of just sit back and relax and just listen. Okay. So this is a reference sheet. Anything raised to 0 power is 1, and we know this, right? So we have some examples. We know that. This is a negative exponent. We talked about that already. That's 1 over x raised to that power. And if you have 1 over x negative, then just reverse. Just go back to the other direction. And lots of examples right here that are shown to that 4 to the negative 2 is 1 over 4 squared. 1 over 3 to the negative 2 is 3 squared. This is new. Fraction exponents. So radicals, I told you, are like exponents or square roots. That's why when I simplified the radicals, I broke that down to separate radicals. It's like an exponent. I can do that. So one thing we have to realize that these are exponents. Like 5 to the half is actually thinking of square roots. Or if I did 3 to the 2/3, that's like cube root 3 squared. So the numerator is like a power. The denominator is like a radical, if that makes sense. So if I have like x to the a over b, it's like the bth radical or bth roots raised to the a power. That's how you can think of it. So if you have like 3 to the 2/3, that's the cube root of 3 squared. Or you can do 3 squared first and then cube root afterwards. Like here, 16 to the 3/4. That's like saying the 4th root of 16 cubed. Or you can cube 16 first, which is kind of crazy, and then do the 4th root afterwards. So I'm going to do some examples in just a moment so you guys can see how that works. But it's really just essentially a root with an exponent at the same time. So you have to break it off in such a way where, okay, I'm doing a radical with a power. And this allows us to kind of do more stuff with exponents down the road. Like in this case, what's that going to be? 17 raised to the 1/3 power, which is a wacky number, of course, right? So that's all it is. It's just, so x is 1/3 in this case. So how would I rewrite these? I do parentheses just to make sure it's not confusing, just so I know what my base is and what my exponent is. That's the only reason I'm doing parentheses. You don't have to use parentheses. I just like to. That's my preference. So we talked about square roots. What exponent is square roots just like as a fraction? 1 over 2. So because it's like saying, we don't write it like this, but it's like there's a 2 to the left of that radical, because you're trying 2 numbers that multiply to 5, which is kind of a wacko decimal, right? What about the next one? 1 over 5, exactly, yes. So that's all it ever is. It's just a fraction. So radicals are fraction exponents. You haven't realized this until probably now, or maybe a while ago you've seen it in some other class, I don't know. But it gives us more possibilities when we're working with exponents later on in your math classes. Especially in calculus, it's huge. You really need to be able to convert that way. So let's think about 81. Then let's work out some of the problems down below, then we can wrap up the notes. So let's look at 81 here. We know this property, right? If you raise something to a power, you multiply. So think about what this means. It means this, or it means this. That's because okay. So let's simmer on this a little bit. 3 halves is your exponents. What 2 numbers, what was law numbers multiplied by 3 halves? But what whole number and fraction multiplied by 3 halves? So this is where fractions, I know because fractions, what grade do you guys do fractions? 4th grade, 5th grade, 6th grade, 6th grade, 4 years ago, we talked about COVID, right? Nate's got COVID now, but he's not gonna kill us, right? Thank you for not killing me. So anyway, so I shouldn't joke about that. That's actually fair. But anyway, you get the point, right? Is that fraction sometimes, you guys didn't learn it as well as you should have, right? Because just society wants to shut down. But so just think of it this way: it's 3 times 1/2, right? 3 halves. It's 3 times, because what's 3 is in fraction? 3 over 1. 3 over 1 times 1 over 2 is still 3 over 2. So you can break it off like this. So that's true. when you multiply these two, you're supposed to get back to that. Or multiply these two, you're supposed to get back to that. So that's how you can look at it. You can look at it like that. Now, let me take this a step further. Let's work it out. This is no different than saying the square root of 16 then cubed. What's the square root of 16? Okay. And what's 4 times 4 times 4? If you don't do that mentally. So good. Thanks, Charlotte. 64. Okay. I should get the same thing for the other one, but can anyone do 16 times 16 times 16 in their head very easily? It's a little hard, right? Actually, I do know.
96.
Actually, I was gonna do it in my head, but I know you didn't.
Yeah.
Okay, what's 16 raised to the fifth power?
1.
Ooh, look at that. All right, that's what I thought. Okay. All right. Okay, anyway. Point being, unless you're John Bartle, it's hard to do in your head. Okay, so you might want to do the radical first and then the power afterwards, or the denominator first, the numerator afterwards. But it's the same thing, right? 16 cubed, 4096, square root 64. So that's how that's supposed to work. So now let's look at the examples below. So guys get some practice with that. And I think we could finish this off. So for each expression below, rewrite it in at least 2 different ways. So you write as a cube root of 10 squared, or the cube root of 10 first, and then squared. It's up to you. Either way gets you the same thing. And that's a wacko number. It's crazy. Here, I could write as y to the 1 power. Or if you feel so desired, you could just do that. It's kind of crazy. I don't know why you'd write that way, but you could. Or for E, actually, let me do D. You can write like this, or you can do 2 to the 5th power first, and then square root. You do that. So those are some options of how to rewrite those. Hmm? How would it do B?
It'd be squared. No, E.
E? Yeah, you do
Square.
root 5, then raise to the 7th power. Or 5 to the 7th power rooted. C, you can do x to the 3/5 power. Or, let me think about this one. You can 5th root and then cube it afterwards. Here you can do 9 to the 4/3. Or you could do 9 to the 4th power. Then cube rooted. So a lot of different ways you could write those. Okay. I think it'd be good for us to finish off this page. But questions on this, what I just did. So all I did is I rewrote a radical. That's a cube root squared. And you could cube root first and square, or the other way around. It's all interchangeable. Or here, it's array of radicals, rise 2 to the 5 halves, or the square root 2 to the 5th power. Same thing. Or here, that's root 5 to the 7th power, or 5 to the 7th power, then root it. So either way, it's interchangeable. It's all the same thing. Just as we saw in the previous example. All right. Let's go ahead and do these examples below. Go and do these in your table groups. I'll come around, just make sure you guys are doing okay. I'll freeze the screen. I'll do it quickly, so I at least know what the answers are. So you can use properties of exponents, just like we've done before. I'll come and help you guys out. And you're gonna have to know your fractions fairly well. 6. Okay, let's try this. Try this out, guys. All right, I'm gonna come around and check. Yeah, go, Jasmine. Yes. You're gonna be adding. Number 9. You're gonna be adding the exponents. Yeah, you're gonna be adding. They do. You got it. Yeah, perfect. Got it.
Are we trying to?
You got them all. Okay, Jasmine, help the group out. You got them all. Good work. Yeah, let's work these out. Spend a few minutes. We'll get homework quizzes after that. Remember, for number 1, you want to multiply the exponents. Likewise for number 2. 9 and 10, you want to add the exponents. And for 10, you have to find the LCD, the least common denominator.
You multiply 2 times.
All right.
And then for the x.
Okay, let's spend a couple minutes on it. See if you got trouble. Yeah, good work. Yeah, got it.
These two are when it's like this, you're actually multiplying.
So 4 times 3 over.
Oh, it's 12 over 2, which is
Yeah,
6.
yeah.
And 30 over 3, which is 10.
Yeah. Oh, you do that 6.
Show me.
Okay.
You guys playing football
Things academy.
down there?
Yeah.
No, it'd be 3. You get 3 times 1. You're not adding 3 plus 1.
Yeah, no, you're adding.
All
But you
The bottom
cancel
four.
out.
The bottom one
You're
second page.
No,
What else do you
no,
need?
but Q plus negative 0.
Right?
Yeah.
You have to add those exponents.
You're left with
That's what I'm about.
Okay, that's not.
3, 6 plus 8, 6.
Is this 4B?
No, that's not class.
no, it's 3.
Where's it building?
Oh,
So-
I see. Friday. Friday, black one? Black one?
So.
You gotta do certain-
Black one.
Well, that's it. Okay.
You're asking for.
Already started.
Yeah.
Very good. That's N6. Good. That's good. You got that. Yeah. Yeah. So then now number 2, do the same thing. But you gotta raise 27 to that power and then P6 to that power.
Wait, is this also right?
Yeah, same thing. Which 2 goes to 12 how many times? 6 times. So it's full N6. So that's another way to write it too, right? Okay, so I know Jasmine, you're helping them out. N6. Okay, the only thing you have to do, you have to do 27 raised to the ninth. You have to do this. And this is good. You got that. Okay, so everything looks good except for that. 27 raised to 5/3 pounds. The same comes in. You did great. Actually, let's do without that. Think about it. No, we can do it. We can do it. No, don't do that. Yes, 27 to the 5th part, let's just go on. You can do it. Yeah,
No.
this one here, you have to do this first.
The first thing you're going to do is 3 times 3, right? Yeah, there's a lot.
So that's 3, and then 3 to the 5th power, which is a little hard in your head, but 3 times 3 equals 3 times 3 times 3.
So 9. 27. Yeah, actually, it's 15, have 15, that's in your head.
So then 243.
I just had memorized actually.
Well, 17.
Guess well, 17 has 17 is 289. I know that. So I've memorized.
I don't know.
I'm sorry, say again? No, it's just 243. No, because what happened was we first did the cube root of it, which is 3. And then I did 3 to the 5th power, which is all this.
Where the P go?
So you're done.
No P?
And then P to the 10 power. You guys got it. Okay, let me show you guys because we start the homework quiz. Here we go. Those are the answers. Okay. So still the same properties of exponents. Make sure that you're adding exponents or multiplying exponents depending on the situation. And if you have any numbers being risen, make sure you take the number, rise it to it. Jasmine, go ahead.
I think you get 243.
243. Oh, I thought you got 243. Oh, sorry. I didn't. That was my fault. So you're not correct about that. That's my fault. My apologies. How do I get that? What I did was I have to do 27 to the 5/3 as well. You forgot to do that. And you have to do that also to the 5/3, which is of course 10. Yeah, I'll start right now. And then the cube root. So you got to do cube root, Jaslyn, and then raise to the 5th power afterwards. That's how I got 243. All right, let's start now. Here we go. Calculator's okay. It's really big. Now give me some like black quizzes. No.
I'll take that.
I'll give time. And yeah, I gotta get faster. So we'll do an alternative next week. You've been Colby. And so yep, your turn, by the way. Gee. Well, let me get in touch. We'll figure something out. Okay, and again, it should be pretty straightforward. Homework's very close to school, G. That should all be there. Let me close this. Stop sharing. Stop recording.